welcome back to the Science Network.
Hold up, we're missing something.
First, most importantly, always wear your goggles and aprons at all times.
Okay.
Second, no running in the lab.
Not without permission. And toed shoes. Never eat in the lab.
Keep areas clean at all times. Make sure your hair is out of your face during all experiments. Types of reactions. Number 1, combination, is when 2 or more reactants form one product. 2, decomposition, when a single compound breaks down into 2 or more simpler substances. Number 3, single displacement, when a move active element displaces another less active element to form a compound. Number 4, double displacement, is when 2 species, normally ions, are displaced. Number 5, combustion, occurs when a compound, usually one containing carbon, combines with the oxygen gas in the air.
Chemical and physical reactions. Physical changes are changes in appearance. Example when including cutting paper, folding clothes, and denting a car. Physical changes do not create a new substance. For example, take a piece of paper and fold it into smaller pieces. This would be a physical change. When ice goes from a solid to a liquid, then a gas, and back, it is a physical change. Many mixtures are a physical change. Mixing salt and water is a physical change because you can separate it later. Chemical reactions create a new substance. It involves the breaking or making new chemical bonds between atoms. Chemical reactions leave behind clues or indicators that a chemical change has occurred. In summary, a physical change is a change in appearance only. A chemical change creates a whole new substance.
The periodic table. At first glance, the periodic table looks very complex. In fact, it is a large grid of every element that exists. The elements are arranged in order of their atomic number. The atomic number is the number of protons each atom has in its nucleus. By arranging the elements in this way, those with similar properties, characteristics, are grouped together. As with any grid, the periodic table has rows running left to right and columns running up and down. Dmitry Mendeleev, Russian, 1834 through 1907. The chemist was convinced there was an order to the elements. He collected information on each one, and in 1869, he published a table of elements on which the modern periodic table is based. He left gaps for elements that he predicted would be found, such as gallium, germanium, and scandium. Groups. There are 18 groups, columns, in the periodic table. Group 1, also known as the alkyl metals, is the column on the far left of the table. Elements in the same group have similar but not identical characteristics. This is because they all have the same number of electrons in their outermost shell. You can tell a lot about an element just by knowing which group it is in. Periods. The properties of the elements across a period, row, change gradually. The first and last elements are very different. The first is a reactive solid. It catches fire when it mixes with oxygen. And the last is an unreactive gas. However, they have the same number of electron shells. All the elements in the third period, for example, have 3 shells for their electrons.
Elements of the periodic table.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the sign, sodium for salty times,
Magnesium.
aluminium, silicon,
Phosphorus.
then sulfur, chlorine, and argon,
Potassium.
and calcium so you'll grow strong,
Scandium.
titanium, vanadium, and chromium, and manganese. This is the periodic table, noble gas is stable, halogens and alkali react aggressively. Each period will see new outer shells while electrons are added moving to the right. Iron is the 26th, and cobalt, nickel coins you get. Copper, zinc, and gallium, germanium, and arsenic. Selenium and rhodium, will krypton helps light up your room. Rubidium and strontium, then yttrium, zirconium,
Niobium,
molybdenum, technetium,
ruthenium,
rhodium, palladium,
silverware,
then cadmium and indium,
tin cans,
antimony, then tellurium, and iodine, and xenon, and then cesium, and barium is 56, and this is where the table splits, where lanthanides have just begun. Lanthanum, cerium, and praseodymium. Neodymium's next to promethium, then 62. Samarium, europium, gadolinium, and terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium. Hafnium, tantalum, tungsten, then we're on to rhenium, osmium, and iridium. Platinum, gold to make you rich till you grow old. Mercury to tell you when it's really cold. Thallium, and lead, the bismuth for your tummy.
polonium,
Astatine would not be yummy.
radon,
Francium will last a little time.
radium,
Then actinides at 89. This is the periodic table. Noble gas is stable. Halogens and alkali react aggressively. Each period will see new outer shells will electrons are to the right. Actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, titanium, fermium, and olevium, nobelium, lawrencium, rutherfordium, wm, sprigium, borium, hesium, neodymium, duxinium, mercurium, copernicium, nihonium, flerovium, moscovium, livermorium, tennessine, and organesson, and then we're done.
Experiment time with Avery.
We doing an experiment!
Avery.
I'm Avery.
And
This is my sister Lace.
we're going to be doing an experiment today
Yeah.
with Diet Coke,
And
the Mentos.
Demeter.
Put it behind mine. Ready? Run. Run! Diet! What happened?
It would glow like this, and he was running. Look at it. Oh, hi guys. We're doing the soda challenge today, and we're gonna get one at a time. And today, and I'm gonna put it in here today, and I'm gonna do this, and I'm going to practice in my soda, and we go do this, and mommy go to do this, and it's not dark, it's dark because we go do the soda challenge today. Are you ready, guys? 1, 2, ready to go. Wait,
Yeah,
I started with my challenge.
good job.
Mentos plus soda produces an impressive fountain of bubbles. But why? Let's say you ask your friends and you search online, but you come up with conflicting answers. Some sources say that sugar reacts with the diet soda to make the fountain. It's a chemical reaction. Other sources say it's a physical reaction caused by the rough texture of the candy.
What do you mean, rough texture? Mentos are smooth and round. It can't be sugar. Soda already has sugar in it. That's why you have to use diet soda.
How are you going to decide who is right? You could choose based on which person you like better, or which website is more entertaining and appealing. But these are not good methods for getting to the facts. There is a reason Mentos react with soda to produce a fountain of bubbles, and with the help of the scientific method, we can figure out which explanation is correct. Let's begin by testing the first explanation we heard, that the reaction is caused by a chemical reaction of sugar and diet soda. If the sugar in our Mentos is the cause of our eruption, then we would expect other sweet candy to produce a similar effect. So let's test jelly beans, gummy bears, and sour watermelon candies. The other candy produced much smaller reactions than the Mentos. The results did not support our hypothesis. Now let's test the second explanation, the idea that the reaction is caused by the rough texture of the Mentos. If a rough texture is all that is needed to produce bubbles, then sand should also produce a reaction. And it does. In fact, when we did this experiment, sand produced a higher fountain and got more of the soda out of the bottle than the Mentos. The results support our hypothesis. This explanation is the correct one. Soda is a carbonated beverage, which means it contains a lot of dissolved gas. That gas wants to come out of solution and form bubbles, but it needs a surface to form on.
This is why you see bubbles along the side of a cup when you pour soda into a glass. Although Mentos candies appear smooth, their microscopic surface is incredibly rough, providing excellent nucleation sites for forming bubbles.
6, 7, 8.
And we're back.
Thanks for watching this week's episode of
Types of reactions
And physical and chemical changes.
And the Periodic Table. See you guys next week.
Bye.
Hey guys! Welcome back to
And we're back.
Oh, it's got me in its bed. A feeling that I know so well. Oh, it's got me in its
Second.
bed.
No running.
A feeling